Hi everyone! I wanted to talk a little today about my PiGFX library for Pascal running on CP/M. It's written in Pascal. It has 3 different versions: a full version with all the features, a small version with some reduced functionality but smaller compile size, and a tiny version that's kind of bare bones. I wanted it to be that way to make it more usable depending on space needs. But since it's open source, I suppose you could eliminate any part of it to make it smaller for whatever you wanted. When I started writing my Pascal toolchain, I wanted to basically make it simpler to use the control codes for PiGFX so that you would not have to manually code long strings each time a control code was sent. Additionally, since most of the strings contain common characters, saving them as constants makes the code tighter. This is an advantage as you can reference back in memory at those constants versus having the same characters stored over and over again in separate strings. My biggest hurdle was getting data over the serial link to the interface efficiently. Since I was kind of learning as I went, I had to test things out with no real way to guess what would work well before I tried it. Additionally, when I started out to build my own games console, I envisioned a completely different Z80 SBC at the heart of it. I had initially picked Grant Searle's breadboard Z80, and I even bought most of the parts and started hand wiring it from scratch. It was kind of a non-starter, but it led me to learn a lot of things about prototyping, mainly that you want to start a project like that on a breadboard and build up a PCB, socket it, and try not to hand wire it when you are a novice.
So before long, I settled on the Z80 MBC2. And I was asking my wife if I could send a guy in Italy $60 plus shipping to buy this kit and solder the whole thing together, and she was like,
Wow, what are you going to use it for?
Games and stuff.
There was also a huge learning curve with the Z80 MBC. That's not knocking it. I love this computer, but the documentation is in the source code for the Arduino Sketch, and it was kind of hard getting used to working that way. I still run into problems occasionally. Most recently, I had an issue with the real-time clock module I talked about in my last video. My main focus was to get everything running fast enough to play a game. I didn't think the existing methods for sending commands to the terminal within Turbo Pascal were fast enough. This is, to say, the write and write line command. There were issues, specifically the cursor, and any time you used the write line or write command, it would move the cursor, so eventually you would need to home the cursor, or the whole terminal would scroll up. This was a problem because even if you shut off the cursor, when you drop the cursor on the corner of the screen, it would overwrite whatever graphics you put there. I was relatively certain this wasn't an issue with the terminal because in testing I'd done without the computer hooked up, just sending raw data, there were no issues. When I started to write the second version of the library, I figured out how to use the port command. The Z80 version of Turbo Pascal has commands for accessing ports of a Z80 processor directly, and through that you can use the specialized OP codes designed for the Z80 MBC2 computer. The one that interested me the most allowed me to write characters directly to the TX pin of the Arduino, bypassing CP/M and its character buffer. It wasn't until I tried to upgrade the library to make it work with collision detection that I discovered BDOS calls. I'd use them to read collisions coming from the terminal and to write a procedure similar to the basic in-key command. I'd done this with BDOS function number 6. It had its own challenges, but it worked well enough for me, so I went with it. I did some more research and found that there was a BDOS procedure for sending characters directly to the screen. I thought that might be a good way to make a version of the graphics library that worked on more versions of CP/M and specifically computers that were not the Z80 MBC. Experimenting with it, I found out it was quite a bit slower than using direct port writes and probably wouldn't be very useful for making my game work. What are the BDOS and BIOS in CP/M? Well, to understand, we should talk a little about the inner workings of CP/M. CP/M running on an 8-bit system essentially is made up of three components: the basic input-output system, or BIOS, the basic disk operating system, or BDOS, and the console command processor, or CCP. The BDOS and BIOS are memory resident all the time, while the CCP is only memory resident when it's not overwritten by something you loaded into memory, like a program. The BIOS controls the computer's access to its devices, such as disks, terminals, and keyboards, as well as controls simple sending and receiving of data between these systems, including sending data to the terminal. BDOS is what you think of when you're talking about an operating system. It controls applications, the file system, and performs operations on top of BIOS. The CCP is the command prompt and all the operating system's COM files, which make up the user side of the operating system. We don't really need to directly access this through programming because all operations up to the point of executing some code, we are in the CCP. If it helps, you can think of it as a program that accesses other programs. It's an oversimplification, but it's good enough. It's also suitable to note it kind of runs alongside the BDOS, providing a command interface for human-readable commands to make accessing the BDOS more tolerable. So generally anything you can do at the CCP can be done through BDOS. Since the BDOS kind of runs on top of BIOS in CP/M, much like the OS runs on top of the BIOS on a PC, I figured it would greatly improve my performance if I could bypass the BDOS, as it was a whole other layer of system that could bog down my commands as I sent them to the terminal. I wanted it to be as fast as possible. So in researching BIOS calls, I found the command conout. It's a BIOS call with the number 4 in decimal in most of the documentation that I was reading. So when I would call BIOS 4,50 from the code in Turbo Pascal, I expected the number 2 to pop up on the display, since 50 is the decimal number for the ASCII character for the number 2. But instead, it would hang or nothing would happen. I couldn't figure out what the issue would be, so I gave up for a while, but that's when I read this. I discovered that when designing Turbo Pascal, possibly in an effort to prevent you from calling BIOS call 0, boot, Borland simply offset the BIOS calls by 1. Therefore, wboot is 0, const is 1, conin is 2, and conout is 3. I had been calling the wrong BIOS call. Well, then it was a simple case of rewriting all the inefficient BDOS calls to support the simpler lower level BIOS calls, and it worked perfectly. So now I had 3 versions of the graphics library, but I wanted to know how to quantify the speed differences. So I threw together this quick benchmark. It's probably not the most scientific benchmark, but it will kick out comparable aggregate values so that you can quantify the differences between the 3 methods. The program has 3 functions that all return a value of a number of operations in 10 seconds. The first function will run our little lines program at a given graphics mode, assigned with this variable right here. It runs the loop until it gets to 10 seconds and then it stops. Our main program runs that loop twice, once at high resolution and once at low. The second function outputs the asterisk character and the line feed character when it gets to the edge of the screen, as many times as it can for 10 seconds. It counts these up. It is important to note the output of this function is literally the number of bytes the computer can send over the link in 10 seconds. That will be important later. The third function is a control test, and it will be more or less the same each run through. It is the same as the last function, but it uses the write statement in Turbo Pascal to send the same asterisk character over the link and counts the number of characters sent. So here it is in action. So here's the output. The number of high-res lines, the number of low-res lines, the number of characters the interface did in text mode using the PIOut statement, which is the direct serial port statement, and then the control group. So then what I did was to run that program under the three modes 5 times each and collect the data. Here's what I found. So what is interesting to note is that the direct port method is maybe only 150 or so more operations in a 10-second period than the BIOS method. But the BDOS method is about half as much slower than both. That's not surprising considering calling the operating system to call the BIOS for you is much slower just in principle. Another interesting thing to note is the text mode performance. This is significant because your ability to send characters to the terminal and then have them processed is everything when you are trying to communicate with a graphics terminal that only uses ASCII control codes over a serial link. So it's not surprising when the BDOS version of the graphics library is the only version to underperform the control group. For the text mode, the abysmal performance was apparent enough for Borland to not use it in their own internal command. So then I thought, I should totally see how that performs when it's plugged into the Tetris program. You know, for science reasons. Here's the performance with the Serial Direct, so you can see how much better it is. Remember before when I talked about the characters test and the output data being significant? Having that data, we can then take the 3,150 bytes, each character is a byte, and divide that by 10 to get 315 bytes per second, or approximately 300 baud. Multiply that by 8 and we get 2,520 bits per second. From Turbo Pascal at the 8 MHz. Why so slow? Well, a couple of reasons. First, the computer is only running at 8 MHz, and while CP/M's involvement is minimal, there is still some performance that is taken up by the BIOS and VDOS managing things like disk access, the terminal, and keyboard. Second, the code is running in Pascal. All the loops, data, and variables, and other ancillary functions are generated by the compiler passing over the code once and then using a set of generic machine code statements that may or may not be the most efficient. But still, take it into perspective, 2.5 kilobits per second? Most VGA interfaces ran on an 8-bit isobus. Those speeds can be measured in megabits, though most SRAM chips of the time were not nearly that fast, and the CPU was often the bottleneck in getting data to the screen. That's also not to mention that the isobus is parallel and this is serial. Well, I hope you guys enjoyed everything I put together. I also put up my sources, finally, on GitHub. I'll put a link in the description so you can take a look at all these examples that I've done. Since the graphics library is ported to more compatible BIOS calls, I'd be interested to see if somebody who's got maybe, say, a RC 2014 or something similar with PiGFX interface running at around 8 MHz to try to get it to run. Well, that about wraps everything up. Thanks again for watching, and stay safe out there. Goodbye!
I've got a feeling that this version of the graphics library is going to be slower on the character test, this one right here, than the built-in console command for Pascal.
Yeah.
I feel like that is a thing. But we'll see. It sure looks like it.